Pre-calculus. These are the notes you will need for lesson 2.4b. This corresponds to lesson 2.7 in your textbook. Before we get started, I'm going to have you fill out just your basic parent functions that we'll need in this lesson. I'm going to expect you to graph your functions today and not just make rough sketches. So when we're graphing y equals x squared, we have some key points that we're going to be graphing. And those key points are 0, 0, 1, 1, negative 1, 1, and 2, 4. And its reflection, negative 2, 4. So again, you guys know this as a quadratic. It's the squaring function, and it's a parabola. When we graph the square root of x, we know that x can be 0 or anything larger. So some key points that you need to be graphing are 0, 0, 1, 1, and 4, 2. The third one is our cubing function. And we talked about briefly in class some key points that you'll need. And you can always do 0, 0, 1, 1, negative 1, negative 1, 2, 8, and so on. So what I want you to realize is that this is not a straight line. 2, 8 is going to be way up here. This is the curve that kind of snakes through here. So make sure you're aware that x to the third decreases on the left, increases on the right. And there you go. Absolute value is next. Key points that we'll want to graph are 0, 0, 1, 1, negative 1, 1, and so on. Those are the same points that we use for a parabola. And this is our V-shaped graph. So make sure you have a nice rigid V. And then the x to the third is the inverse of the cube root of x, which is what I have here, is the inverse of x to the third. So for an inverse, we're going to just flip our points around. So the cube root of 0 is still 0. The cube root of 1 is still 1. The cube root of negative 1 is negative 1. So it looks like right now that these points are exactly the same. But if you take the cube root of 8, you would get 2. So 8, 2 is a point. This graph actually snakes through this way. All right, those are the parent functions you need to be aware of as we proceed through the lesson. So the first part of the lesson is just how to obtain a vertical shift. And you can obtain a vertical shift by adding or subtracting a number outside of your function. So this one shows that you're adding 2, which moves your graph up 2. Now you guys should know that already, so this should be a review for you. If you want to move something left or right, then that has to take place within the function. So subtracting 2 on the inside is the same as having a parabola whose vertex is at 2, 0. So if you equate that to vertex form, or standard form, your h and your k make up your vertex, and your h and k for our problem is 2, 0. So we have the 2 right here, and then you're just adding 0 on the end. So it's the same thing as taking x squared and moving it right 2. Vertex is 2, 0. All right, so this summary tells you all about your shifts. Outside of the function is adding or subtracting outside the function is vertical. Within will be horizontal, and it's always the opposite. And so we're going to practice that with these two problems here. Now, when you do these, I would like for you to sketch your parent function first. So I'm going to sketch this. I'll do that in black. 0, 0, 1, 1, negative 1, negative 1. I could even graph 2, 8 and negative 2, negative 8. There's my parent function. I'm going to label that F. And then I'm going to take in my different color, I'll use the pink color, I'm going to graph G. And G is shifted down 1. So this means down 1. So I'm going to take every point and just move them down 1. And then redraw my graph. So this translation is pretty small on my grid because the squares are so small, but I just moved my shape down 1, and that's G. For this one, I'm going to, again, start with my parent function, 0, 0, 1, 1, negative 1, negative 1, 2, 8, negative 2, negative 8. So here's my parent function, and that is F. And I'm going to do what this says now. So the plus 1 is taking my graph up 1. And this right here is taking my graph left 2. So remember, inside the parentheses, you're going to do the opposite, and that's always a left right. So I'm going to take every point and shift them up 1, and left 2. Up 1, left 2. Up 1, left 2, up 1, left 2, and up 1, left 2. And then I have my new cubic function. Almost got it. I'm going to try one more time to hit all my points. Got my new cubic function right here, and that is H. So whenever you guys do your practice problem, it will tell you to graph your parent function first and then put g of x on the same coordinate plane. So each of these should have 2 graphs. You should have f of x and g of x on each graph. Reflections. If your negative is outside of your function, that is going to be an x-axis reflection. So something like this. Or if I had negative radical x, that's an x-axis reflection, or negative x to the third, that's an x-axis reflection. It's negating your y, so that would make sense to flip it over the x-axis. If the negative shows up within, then that's a y-axis reflection. So in summary, here's your reflection rules. Again, this might be like y equals negative x squared, y equals negative x to the third, y equals negative absolute value of x, etc. If you're going to reflect something across the y-axis, here's a popular one, we take the square root of negative x. Instead of having the square root of x this way, the negative will flip it back this way. All right, now as you get into higher powers of x, they all mimic each other. So the even powers are all going to look like parabolas. It's just the higher you go in power, the flatter the curve gets at 0, 0. So you can see here that this one's pretty flat, and that's because it's to the 4th power. So we're going to use x to the 4th as our parent function. And we're going to try to write an equation for each of these. So I can see that x to the 4th has been shifted up 2 because normally it's here at 0, 0. And it's also flipped upside down. So chances are they might have started here. I think the sequence of events would have been, here's my original, something like that. Then I flipped it over, something like that. And then I took that and I moved it up 2. I hope that makes sense. So again, I'm starting with x to the 4th. Let's see, this is g, so g of x. And I flipped it over, so negative x to the 4th. And then I moved it up 2. And this one, you can see that it's been flipped over again, but also pulled to the right 3 spaces. So this is a distance of 3. So g of x, negative for the flip, x minus 3 to the 4th power. So that minus 3 goes to the right 3. And then what you're going to have here are some graphs. Things have been translated. Here's the original function. Can you give me your new equation? Non-rigid. These are the ones that change and distort the shape. So these are typically vertical stretches or shrinks, or horizontal stretches or shrinks. So let me just kind of talk to you about these, and I'm just scrolling ahead here to see what we have. Okay, I typically stick with the vertical stretches and shrinks. So when it says here that c is between 0 and 1, so these are fractions, that's going to be a shrink. And when c is bigger than 1, that will be a vertical stretch. So this is a vertical stretch by a factor of 3. This is a vertical shrink by a factor of 1/3. Okay, so to graph this, I'm going to go ahead and graph the absolute value of x first. I'm going to do my parent function again in black, 1, 1, 2, 2, 3, 3, etc. That side's not very straight. Okay. And then if I'm going to graph this one, 0, 0 is still a point, but when I put in -1 or 1, now I get 3. So 1, 3, 1, 2, 3, and so on. So you can see that it's going to stretch it vertically and make it much skinnier. Try to make those straight. It's hard to for me to do that on my iPad. All right, for 1/3, it's going to be wider because that's what a vertical shrink does. So my original again, coming through. All right, kind of cuts each quadrant in half there. And then if I want to graph the original one, but 1/3 of that, 0, 0 is fine. 1 or -1 will be 1/3. That means 3 would be 1. So if I go 1, 2, 3, 1, 1, 2, 3, 1, you can see how much wider it's going to be. So a vertical shrink makes something much wider. All right, another good thing to do here would be to label. So my original was F. In this case, my purple one is H, and my new one here is G. All right, that should be a good review of translations. This is all stuff you've done in Algebra 2. Let's see, I should clarify that on this slide, the square root of x is your parent function. So just ignore that little box right there. Again, ignore that little box, ignore that little box. It doesn't need to be there. So g of x is just negative radical x plus 2 minus 3. And then when you get down here, you're going to use these functions to write equations. And again, on this one, ignore the little box. Okay, that should take care of you guys. Let me know if you have any questions.